Okay. So, actually, that's not what I want. So, this problem we've actually seen before. When you were doing finding the height of the light pole by stage 2 local or in stage 2 distant for either the cell tower or my 4th period class, we're trying to find the height of a flagpole on top of the Mesa building. This is what happened. We're ignoring the eyeball height thing here. This is just how you'd find the height above your eyeball for the tower, and then you'd have to add the height that your viewing point was above the ground. So we're isolating to just this one part. And what you did was you got to one point, you looked at the tall object you were trying to measure, and you got an angle of elevation. That's what this 52.5 degrees would be. You then backed up. I think out in the field we backed up 100 feet or so, 100, 150, I forget. And from that point, you measured another angle. That would be the 34.1. You did not know how far your measuring points were from the target, but you knew how far your measuring points were from each other. So this is the problem that you have to solve in order to use that method 2, which is the method you have to use to find the height of the tower over at the mall. Now, when we did this in class, well, we're asked to find this. So I'm going to take this length and label it y. And we're not explicitly asked to find how far the target is from that first observation point. I did ask that question for the cell phone tower over at the mall. This is some unknown distance. I'm going to call it x. Now, how can we tie some trigonometry into this? Some stuff about right triangles. And what we've just done, you've taken your unknown side and your known side, and you've set up a trig ratio. In this case, we don't have any known sides of a right triangle. We have, in the smaller triangle, don't know how that happened. Oh, in the smaller triangle, we have a height we're trying to find. We do know how far apart the two observation points are, but we don't know how far either one of them is from the pole. This smaller right triangle with corners here, here, and here. The best we can hope for is to write a trig ratio that involves the two unknowns that we're trying to find, or the two things we don't know. So what's a ratio that involves y and x and 52.5 degrees? We've got from the 52.5, the y is which side? Okay, this is opposite. The x is adjacent, so the tangent ratio comes up. So if you look back at your notes from those days, one of the things we did is we wrote something like this. Y over x equals the tangent of an angle, 52.5 degrees. And we probably went through and rewrote that, so I'm going to rewrite that in just a second. Whoops. There. And then, well, there's one other right triangle in the picture. So that right triangle is the large one, whose vertices are over here at the 34.4 degrees, and up here at the top of the pole, and down here at the bottom of the pole. And when we look at that, y is still the opposite side. The adjacent side is now x plus 126. And so we can write y over x plus 126 equals the tangent of 34.1 degrees. So, let's see, insert, and I want to put a blank page in here. So what I'm going to do is I want to take this much. Actually, I want to come back over here and hit that, and then come back over here. And I want to rewrite this as y equals x tangent 52.5 and y equals x plus 126 times the tangent of 34.1 degrees. Now, what I see here is I've got two linear equations, right? Y equals the slope times x. The slope here is tangent of 52.5. That's a line whose graph goes through the origin. This one doesn't go through the origin. The slope, if I distribute the tangent of 34.1, the slope is the tangent of 34.1. And then the y-intercept is going to be 126 times the tangent of 34.1. I don't need to worry about that, but the bottom line is the only unknown on the right-hand side is x. This is y equals a number times x, or y equals a number times x plus another number. So both of these are linear equations. So, let's see, snipping tool. Let's take this picture and let's come over here and paste it.
Can I go something else? My eye is really bothering me.
So I'm going to set that up. Can you maybe go try to wipe it out in the restroom? We are recording right now, so I don't.
Sorry.
It's okay. Because that's the first thing she's going to ask you to do. So anyway, what we have is these two linear equations. So if we take y equals x times the number tangent of 52.5 and y equals x plus 126 times the tangent of 34.1. What do you know about solving two linear equations and two unknowns?
Plug in, put one together.
Okay, one of the things we know is we're trying to find a point where the two lines meet, right? They cross, like I got my arms crossed here. Now, that point where the two lines meet, the y-coordinate is gotten by multiplying the x by tangent of 52.5. But the y-coordinate at that one point is also gotten by adding 126 to the x-coordinate and multiplying the result by tangent of 34.1. So the idea of substitution is to take the two expressions for y, substitute one of them into the other equation. So if we're going to solve this algebraically, we get x times tangent of 52.5 is equal to, well, on the right-hand side, I'm going to distribute the second one, x tangent of 34.1 plus 126 tangent of 34. So, when we're trying to solve this for x, we've got an x term here and an x term here. We move all the x stuff over to one side, and so we get an equation that says x times tangent of 52.5 minus x times tangent of 34.1, and if they both have a factor of x, so I've gone ahead and done another step and factored out the common factor of x. And over here I have 126 tangent of 34.1. And so my x value is 126 times tangent of 34.1 divided by tangent of 52.5 minus tangent of 34.1. And that doesn't tell me the height of the pole. That tells me how far away the pole is from that first point. All right, that's x in the picture here. So, but in principle now, we've got a known side and an angle, and we're trying to find another side. Right? You've already seen that you can do that. That's the last two problems that we just did, right? If you have if you're given one side and an angle, you can find the missing side by looking at an appropriate trig ratio. And in fact, we have just the equation we need right up here. If we want to know the height, it's just the x value times the tangent of 52.5. So that x value, since we can get it, 126 times tangent of 34. So if we just take 126 times tangent of 34 degrees divided by tangent of 52.5 minus, whoops, got to close that parenthesis to make the tangent of just that angle, minus tangent of 34.1, and close the parentheses. My x value is 135.73. So if I come over here, this is 135.73, and then my y is equal to x times the tangent of 52.5.
Other calculator, I think you missed the decimal place. 34.1.
Wait. Did I?
It's just 34.
Oh. Minor error in that answer, so we'll see see how big of a difference it makes. Thank you for pointing that out. So insert 0.1, we'll recalculate that. Oh, we get 136.24. That 1/10 of a degree would have completely messed everything up. So that was a good catch, 136.24. So this should be 136.24. And then y equals x times the tangent of 52. Again, I'm not going to round that and then multiply by the tangent of 52. I'm going to take that answer. I'm just going to hit times tangent of 52.5. And what I get is 177.5, because on this problem I ask you to round it to the nearest tenth of a foot. So rounding it to the nearest tenth, according to the instructions, I get 177.5. And so that would be the answer that I put in.
So y equals what?
So y is 177.5 feet. But on the answer document, I just asked you to put in the actual number, 7.5. So that'll be the answer we submit. But we also saw another way to solve this thing. And I want to quickly look at how to do that. Did I get it right?
177.5? Yes.
Okay.
Just 177.5.
Yeah.
Okay.
A lot of people are kind of put off by the algebra, right? They really struggle with solving a system of equations. That kind of saddens me because I have people struggling with this who, had mastery level scores on the end of course test last year. But if you don't use it for a while, you tend to kind of lose it. It's worth struggling with this a little bit because you have Algebra 2 coming up in your future, right after geometry. But right now you'd like an alternative for this, and I want to remind you the other way we did this. So the second day we did a problem like this, I came in and said, let's do it on the calculator. Right? Your calculator has some very powerful tools. You have this function y equals x tangent 52.5. I can put that in y1. In y2, I can put y2 equals x plus 126 times the tangent of 34.1. So if I do that, go over to the calculator, and your calculator probably often would be in standard window. If I go in and I put y equals x times tangent of 52.5, and then I come down here and say, let's take y equals x plus 126 times tangent of 34.1. Well, when I ask it for the graph, depending on your window, you may see little or nothing of the graph. The first line is blue, and it's a line through the origin, like we said it would be. But when I look at numbers like 126, which is part of the length of the bottom side we're trying to find. I figure that the reason we're not seeing the other line is because this window only goes from minus 10 to 10 in both directions. So I can experiment a little bit. For instance, I can say I don't care about negative values. I can have x go from 0 up to 200 and make it count by something reasonable like 25s or 50s or something. I can let y go from 0 to 200. Now, this may or may not show me what I need to see. If it doesn't, I'll go adjust the window again. I just keep adjusting it. What I'm looking for is where these two lines meet. In the first window, I didn't even see but one line. So, y scale, I'll go ahead and set that to 25. And now I get the blue line coming up, followed by the red line. If I'd only gone up to 150 or 100 instead of 200, I would have missed the intersection. I have to enlarge the window. But I could tell, even at the beginning of the lines, the red one's not as steep, and so they're going to meet at some point. I just need to make the window big enough to see it. I could use the trace function to try and find the point where they meet, but when you trace, it goes in little jumps, right? Because there's not an infinite number of pixels going across the screen. And you need to get an answer accurate to 1/10 of a foot. So you probably don't want to use trace. Does anybody remember how we did this?
Second trace.
The second trace on a graph, there's a calculate feature. So once I've got the graph, I can hit second trace or second calc. And of all the things I could do here, I'm looking for the intersection of two lines or two functions. So that's option 5. And it pops up and it highlights one of them and it's in blue and it says, hey, is this the first curve you want? And it asks me as a question down here at the lower left of the graph. Well, that's the one I want, so I hit enter. And then it jumps to another graph in the picture. If that's not the one I want, I use the arrow keys and toggle to the one I want. But that's the one that I want. And then it asks me for a guess, because the way it does this is you put in a guess, it cooks it a little bit and comes up with a better guess, which it then cooks and comes up with a better guess, and it generates a sequence of numbers, and once they match 2 or 3 in a row out to 8 decimal places or 5 decimal places, it says, good enough. It's not solving it the way we did a minute ago. It's not solving it intelligently, algebraically. It is blindly saying, that guess is closer but not enough, that guess is closer but not enough, and eventually it gets guesses that are so close to each other it says I'm done. I'm just going to guess wherever the cursor happens to be by hitting enter. And it solves the problem and says that I get out to 5 decimal places. It will guarantee the accuracy to 5 places. That my intersection is at x equals 136.24, and we said 177.5 was the y value. So it solves the system of equations geometrically, looking at where the two lines meet and estimating that as well as it can. Yes, sir?
I typed in 178, so it was wrong.
Because it's got to be 177.5.
Oh, it has to be exact.
Right, it said to the nearest 10th. Not exact, it said put the answer in to the nearest 10th. I think I went up and down a tenth. I probably would have counted 177.6 or 177.4 is correct. But when I get this answer, we put it in as 177.5. 177.5. And now I've put in all the answers. I'm going to hit submit. And submit the response. Yes. And now we can see whether we got them right. And this is the part where I get a little nervous, because after all that and recording it, perhaps I messed the whole thing up. In which case, people in 4th period are just toast, because they've got a really bad explanation recorded on video forever. So we can look and view the score online. 10 out of 10. Wonderful.
We're awesome smart.
So, 0.41, 3.24 was the answer to F2. 33.13 is this one. 37.04. And lastly, 177.5. Let me stop the recording of that, because we've already gone further than we probably need to on that.